All right, let's talk about another new concept under statistics called as coefficient of range. And if you recall my last episode, we were talking about measures of variability as a whole, and within that, we started over the range part in the context of absolute measures of variability or dispersion. But like we know, every measure has a corresponding relative measure, and the corresponding relative measure for range is coefficient of range. So if you see this hierarchy in another way, we have just taken the range. In the last episodes, we discussed about this, and in this episode or the next few episodes, starting with this, we're going to talk about the relative measure for range, which is also called as coefficient of range. That's what we're going to talk about. Okay, so let's get into this and see what's going on. The first and fundamental question is, why do we need a relative measure for the range? Because earlier we spoke about in general, why do we need a relative measure? And if you recall, I gave the example of two students who are scoring marks. For example, one student is scoring 70 out of 100, and one student is scoring, say, 60 out of 100. Okay, in this case, it's an absolute measure will work. But if the student is scoring 70 out of 100 here and this student is scoring 100 out of 200, the base is varying. So in this case, we'll have to convert this into a percentage, which is nothing but a ratio or a relative measure, so that we can compare the percentage marks. We cannot compare the absolute marks because the base is kind of different. I explained this example in detail in the previous video when we were talking about the fundamentals of variability and understanding the concepts of variability. Just check out that episode in case you need a refresher. Nevertheless, so we always need the relative measure to get a better perspective of what's going on. But let's try to understand, before we get into this relative measure of coefficient of range, what is the problem with its counterpart on the absolute side? What is the problem with the absolute measure, that is a range? And why do we need to use this specific concept in the context of range? Let's understand that. Maybe a couple of examples I'll give you, and then that should be clear. Okay, so if you talk about the range in the previous episode, you could recall that I was taking the example of a smartphone shopping on the Amazon. So let's try to just rework that problem. Okay, so what we can do is assume that there are two shops. Okay, shop A and shop B, both are stocking up smartphones. And shop A, the range of smartphones in terms of cost is between 1,000 and 5,000. And for shop B, the range of smartphone is slightly expensive. It starts from 10,000 and it goes up to 20,000. That's what it is. So we know how to calculate the range. We take the largest value and we subtract from the smallest value over here. So we have largest value minus smallest value. In this case, it's going to be 5,000 minus 1,000 and we get 4,000. And in the bottom case, we get 20,000 minus 10,000, which is 10,000. So if you just compare these absolute numbers just for the concept of range, we can clearly tell that shop B has a better variability or better range, or more, there is more variability in the range in the values in shop B than shop A. We can say that. But let's assume that all of a sudden shop A gets a new shipment, and in that shipment there is one piece of iPhone, just one piece, okay, which is costing a lakh, which is just the normal cost of iPhone. Then what happens is, in this range, if you see, let me remove this over here. If you see in this range, in the original range, it was going from 1,000 on the lower side to 5,000 on the higher side. Just putting one iPhone in the mix kind of skews the range, skews the word. That means it distorts the range. So what happens? The lower range is still 1,000, but the upper range is 1 lakh now, okay? And that's what is happening. So if I calculate the range in today after the iPhone is stocked, then it becomes the largest value, which is 1 lakh over here, 1 lakh rupees, minus the smallest value, which is 1,000. Then it becomes 99,000. So what it means is, now 99,000 is the value of the range in terms of variability for the range of smartphones for shop A. So in this case, and shop B is still at 10,000. So it looks like shop A has more variability or more range than shop B, because 99K is greater than 10K, okay? But that is not true, because, or that is not necessarily true. Just one iPhone putting in the mix kind of completely distorts it. So what in essence happens, the fundamental problem with the range is it does not really care about what are the in between values, what are the intermediate values between the smallest value and the largest value. It does not just really care about that. You can put as many as values you want, and there might not be even any variance in that, but just based on the extreme values, that is the outermost values, the smallest side on the left and the largest values, that those are called as outliers. So based on these two values, the range computes a different value, and which can completely distort the whole the measure of variabilities. And that's not kind of the right way to look at that, because in certain cases it might work and in certain cases it might not work. And that hence that's the reason where we need kind of a measure which still talks about range but in relative format, where we can compare apples to apple and we can really tell which part has more variance as compared to its neighborhood or vice versa. So that's the whole concept. So the keywords here are outliers. New words I'm introducing. Outliers means like this value over here, 1 lakh is an outlier. It's an exception. Just because one exception kind of it throws the value. Okay, and range just focus on the min and max value. So that's kind of the problem with this absolute measure of range, and hence we need a relative measure called as coefficient of range. That's what we are trying to learn. We need a measure called as coefficient of range. Okay, now how is coefficient of range calculated? It's pretty simple. It's a ratio of number, because when we put a ratio of numbers, we remove kind of the denomination where we're trying to compare two different things, just like how in percentage everything is multiplied by 100 to get the percentage. Doesn't matter what the denominator is, and as long as it's computed as a percentage, we can compare them, right? So it's the same concept. So the coefficient of range is defined as a ratio of two numbers, and the numerator is still the normal range where you get the difference of the largest value and the smallest value. And in the denominator, you do the opposite. You take the largest value and add the smallest value. So what happens is you get two numbers, and you are removing the bias for these two numbers, because if you just take the difference, it may not work. So what you do is, for the numerator, you take the difference of the largest and the smallest value, and in the denominator you add those two exact things, and then take the ratio of that. If you see here, largest minus smallest, divide the whole divided by largest plus smallest. Okay, in that case, when you put the ratio, which I'll explain giving an example how it works, whatever value you get, now you will get the value as coefficient of range. And the difference will be, in the above case, you will still get the unit. For example, when we say the range is 99,000 rupees, it's still rupees over here. The unit is still retained, because whether it's going to be height or marks or rupees, the unit is still retained. Whereas in this case, since it's a ratio of two numbers, the units, for example, you might say 5,000 rupees divided by 10,000 rupees, 5,000 and 10,000. This rupees gets cancelled, the unit gets cancelled. So coefficient of range becomes unitless. There is no unit. Just like how you have a percentage, when you have a two ratio of two numbers, it gets cancelled and there is nothing there. There is no unit unless you convert that into 100 and then you put a percentage as a unit. If you don't do that, just ratio of two numbers may not have a unit. So that's one side note where coefficient of range may not have a unit. It's unitless. Okay. Now let's try to see with an example this concept really works. Okay. And okay, so let's take a score of a student in 5 subjects for semester 1 maths. Okay, that's what we're talking about, basic maths. And okay, let's talk about that. So let's say there is a student in a particular semester, and let's say that we have score for his 5 subjects. In one of the patterns, the student has given during the COVID an online exam, which is more of an MCQ for 40 marks, and these are the marks for the 5 subjects. And in another world, the same student appeared during the non-COVID times for the same 5 subjects in an offline mode, which is the theory marks for 70, and this kind of were his marks. Okay, so now we are comparing. What we need to compare is, where is the student consistent? Is he scoring better for the same set of 5 subjects? Is the student doing better in the MCQ world, or is he doing better in the offline world, which is the theory marks for 70, a theory paper for 70 marks. So we are comparing online exam versus offline. That's what we are trying to compare. Online versus offline, to see in net where the student is more consistent, or in net where the student is more varying across marks. Okay, so let's kind of define that. And that's a question I have put here. In which exam pattern, online or offline, there was more variance in the student's score or marks? Okay, let's try to calculate that. So we have this, we are going to rewrite this. So we have the marks over here for online, and we have the marks here for offline. Okay, and let's first calculate the range in a simple way. The range is nothing but the largest value minus the smallest value. The largest value is in orange, the smallest value is in blue. So we just compute 20 minus 10 in this case over here is equal to 10, and in this case 50 minus 30 is equal to 20. So we have these values. So now we can see that, and I've not computed the coefficient of range, we're just talking about the absolute measure, which is the range. Okay, so now we see based on this that the variance or the range 10 is less than 20. Okay, so the range in offline is more, or the variance here is more. So based on that, what we can conclude, the range of offline exam is greater than the range of online exam, because 20 is greater than 10. We get that. Okay, that means what we are trying to say is there is more variance, because this number is higher. There is more variance in the student marks in the offline world, because this is where the 20 is. So we are saying the student mark is less consistent in the offline world. But let's check out if it's really true by calculating the ratio of two numbers in the coefficient of range formula. Okay, so I'm going to still retain the range formula over here as we calculate above. So I'm just trying to calculate the coefficient of range, which is nothing but largest minus smallest. Largest minus smallest over largest plus smallest. Okay, this is still the range value, so we can still borrow it from the calculation that we did. For example, the numerator is still the same over here, same numerator, so we get 10, but we add the two numbers in denominator and we get 0.33. It is unitless, it's just a ratio, so no unit. Okay, and similarly the numerator is same over here, and the denominator we add this largest value and the smallest value, and we get 80, and the ratio of the two numbers in the final answer is 0.25. So for C here, for the MCQ, now the MCQ has 0.33 and coefficient of range, and the offline is 0.25. Okay, so 0.33 is greater than 0.25. So this says that the online has more variance than the offline. That means the student were more consistent in the offline, whereas if you just take the range, is the opposite, because if you see this number over here is lesser than this, whereas this number over here is bigger than this, and hence kind of range is taken in absolute way to see what exactly is going on. It does not tell the details because it does not calculate it properly in terms of how should we think about that, and hence we need a coefficient of range in certain cases like this case, where we need to have a proper evaluation to see where there is more consistency and where there is more variance. And this is a classic example which kind of proves that. So what do we conclude here? The coefficient of the range for online exam is greater than the coefficient of the range for offline. In other words, the student has more stable marks or less variance in the offline pattern than the online. Okay, because the greater the number, the more the range, the more the variability. So it works in the opposite way. So the more the variability, less the consistency. So the more the number, less the consistency, or the more the variance, less the consistency. Okay, that's how we kind of conclude that. And that's kind of the kind of a quick summary of why we need coefficient of range. It's very easy from an exam standpoint of view, easy score, and this is how it's calculated. And I've also explained the context why it is calculated, because you will not find this kind of explanation in any of the textbooks. Why do we even need that, and what is the concept behind this? And this kind of I just wanted to open up that door of thinking on why should we require it. That way it kind of cements your thought process and you can really get the concept. So that's kind of the wrap up on this episode on coefficient of range, and we'll get into next episodes where we solve some problems or something else. We'll figure out what we need to do. And as always, this is one of the sites where I borrowed some of the content or just got inspiration. Actually, this whole problem, this number set, I borrowed from this particular website, although I kind of I fitted this into a construct of MCQ online and offline, but they had a different construct. You can read through that, but I just borrowed the numbers for explaining it in a simpler way. So thanks to this website for giving those guidance. So that's a wrap up on this, and I'll see you in the next episode. So we have covered range and we also covered coefficient of range. So we are making good progress on both the sides. Thank you.